Welcome to our channel. In this session, we are going to discuss about circular linked list. What is mean by linked list? Simply, it is a linear data structure in which the set of elements are organized in some sequential fashion. Always, the last node of the linked list is null. Whether you are using a single linked list or double linked list, the last node consists of the null in their next field. Coming to circular linked list, circular means, for example, these are some set of nodes. Always the last node points to the first node. That means they are rotated in a circular fashion. You got the point? That means there is no concept of null in the next field. If we have 5 elements, the fifth element always points to the first element. Now, this circular linked list is implemented by using either single or double linked list. That means either circular single linked list or circular double linked list. Now, in this session, first we are moving with circular single linked list. Clear? Before going to this, what are the step-by-step procedure? The first thing is, if you want to do insertion, you must and should create one node. You need to create one node. For this node, here which linked list I am using? I am using single linked list, means my node consists of two parts. The first part is the data field and the next part, that is the second part, is the next field. Next field in the sense the address of the next element in the linked list. For this node creation, I am using one class. So my class name is node. Within this class, I am declaring these two variables, and by using constructor, I am initialize the variables. Initialize the variables. So whenever you are creating an object for this class, means obviously one node is created. That is the thing. Now I will write down up to this point. Okay. First class circular linked list. This is my class name. Within this class, I am doing all my operations, all the insertions, deletions, all the operations are performed here. Before that, I am creating one more class, class node. Within this node, what I am doing? What are the required fields? One is data field, second one is address field. So what is the data type of the address? The class name. The class name is also a data type. This is a user-defined data type. Now, by using constructor, initialize the value data. Anyway, no, next is not at all initialized. Why? Initially, the next field, whenever a new node is created, its next consists of null. This dot data is equal to data. Now, what is the value of next? Next is equal to null. Close the constructor and close the class. Remember one thing. Here you no need to give next is equal to null. Even though you are not giving, not a problem. Why? Whenever this is created, by default, the value is equal to null. Clear? Like this, one node class is created. Now, I am creating one more node. The name I used as head. What is the purpose of this node? Always the starting node is referred by using head according to my program. Why? In the linked list, the elements are at any position. By using the first node address only, it is possible to find out the address of the remaining elements. That is the point. Clear? Now move to the first thing. What is the first step? Insert a node at the beginning of the linked list. That is circular. So my thing is, I am doing insertion operation. The three possible insertions are, we are insert a node at the beginning, or insert a node at the end, or insert a node at any given position. First my logic is insert a node at the beginning. Before insertion, what is the step? Create a node. How do you create a node? You already created one class. Class name is node. Suppose my object name I assumed as this is equal to new node of data. Observe, this is the syntax for creating an object for this class. Whenever an object is created, the constructor is executed and this data is assigned to the data field and the object has some memory. Now that memory is termed as a new node. Fine. Now coming to step by step. While insertion, what is the first condition? Initially, the list is empty, means whatever the node you created, that is the first node. How do you check whether the list is empty or not? Initially, head is equal to null. Sir, how can you say head is equal to null? Observe, here I just declared head. Whenever you are using just declaration, by default the value is equal to null. Head is equal to null means there is no element in the list. Now this is the node that we create. What is the name? The name is new node. Because of this step, one new node is created. Whenever head is equal to null, what is your aim? You need to make this node as the head node. How do you make? Simply head is equal to new node. Obviously, whatever the address, suppose address is 1000. Now, what is the head address? 1000. Okay, clear. Here, assume the value is equal to 20. What is the new node next field? Whenever new node is created, the next field is null only. Here, because of the statement, now the new node becomes head. Is it right or wrong? Wrong. Why? In a circular linked list, the last node always points to the first node. The last node does not consist of null. Anyway, this is the first node, this is the last node. The next field points to this only. Means, what is the next field? Head dot next. Head dot next. It is pointed to head only. Because by using these steps, the first created node is the new node and the next field again points to same position. Coming to else. What is the meaning of else? A list is already created. Assume this is the circular linked list. Yes or no, head? This is the circular linked list. What is your aim? You need to insert a node at the beginning. The node some value is equal to 20 and is equal to null. The name is new node. What is your aim? Here the simple logic is new node dot next is equal to head. But if you are written the statement like this, new node dot next is equal to head. Because of the statement, what happened? This link is established. But what is the problem? The last node always points to the first node. The last node always points to the first node. Here, how you can do that operation? Simply multiple ways. I will explain two ways. See this one. New node dot next is equal to head. This link is established. Now head is equal to new node. What is the meaning of this one? From now onwards, whatever the new node that is referred by head. Now this is referred by head and this one. The last node next to field points to this one. How? That means even though we are inserting a node at the beginning, you need to reach the end of the list. You got the point? Why? The last node always points to the first node. You need to know the position of last node. That is the reason what I am doing. I assume one temporary variable Initially, temp is equal to head. My aim is reach the end of the list. How can you say that the node is list is emptied? The next field for any node, if the next field consists of the address of head. Clear? While temp dot next is not equal to head. In the single linked list, you are writing the condition null. Why? The last node, the next field is null. But here, this is a circular list. In the circular list, the last node points to the first node. Whenever it is not equal to head means temp is equal to temp dot next. See this one. Initially, this is the temp node. The next not equal to head. This is the temp node. The next not equal to head. This is the temp node. Yes. Here the next not equal to head. The condition false. Now you know the temp node. Anyway, you know the logic. Temp dot next is equal to new node. New node dot next is equal to head. And head is equal to new node. This is the way to write the logic for insert a node at the beginning. Clear? Now again I will explain step by step. Public node insert begin of into some data. Okay, within this one, what is the first step? The first step is you need to create a node. At any point while insertion, the first step is you need to create a node. My name is this new node. New node of simply whatever the data you received, simply pass the data. One node is created, fine. First check the condition. If the list is empty means if head is equal to null means whatever the node you created, that is the head node. That means head is equal to new node. Along with by default the next field is null, but your aim is that node next is equal to same. Why? Because initially empty, you have only one node. That node points to the same node only. That node points to the same node only. Else. What is the meaning of else? Else means the list consists of more than one element. In that situation, what is the thing? You need to traverse the end of the list. For that, I am using one temporary variable. Initially, the temporary variable points to the first node. Whenever it is not equal to head, why not equal to head? The last node always points to the next node, or that is head node. Temp is equal to temp dot next. My loop is completed. Once coming out of the loop, make the connections. New node dot next is equal to head. The first link is established and temp dot next is equal to new node. Now head is equal to new node. Suppose if the third line is written as the second line, then temp dot next is equal to head. You need to write like this. Once else is completed, return head, that is written the starting position. Now this is insert at the beginning of the circular linked list, especially in circular single linked list. Now move to insert a node at the end of the list. Insert a node at the end of the list. Here also the first step is create one node. That is fine. After creation of a node, if head is equal to null, do the same operation. Suppose else consists of more than one element. Consists of more than one element like this. This is head node. What is the procedure? You need to reach the end of the list. You know the logic. So temp dot next not equal to null. By using this statement, I am reaching the end of the list. Now, here you need to insert the node. Here you need to insert the node. Now, what is the logic? Very simple. Temp dot next is equal to new node. Now new node is the last node. Next new node dot next is equal to head. You got it? Simple example. Insert at deletion is very simple. Now see the logic. insert at end. What I am doing? If head is equal to null means whether insert at beginning or insert end same. Otherwise, no temp is equal to head. By using this loop, I am reaching the end of the list. Now, what is the logic here? The last node now pointed by temp. So temp dot next is equal to new node. That means the right side link is formed. Now, new node dot next is equal to head means the last node now points to the head node. This is inserting a node at the end of the list. Clear? Very simple. Now, insert a node at specific position. What is the concept here? As usual, first you need to create a node. Anyway, if head position is equal to 0, here I am doing the operation like this. If position is equal to 0 means simply call insert begin. Yes or no? Position is equal to 0 means we are inserting at the beginning of the list. Simply call the method. Already the method is available. Else means position is greater than 0. Suppose this is the list I have. This is the list. This is the head node. Position 0, 1, 2, 3, 4. These are the positions. Now, identify the logic one step by step. Suppose I return the logic like this. For int, I is equal to 0, I less than position minus 1, I plus plus. Suppose I have one more node 5. Always the last node points to the first node. I given position is equal to 3 means you need to insert a node. This is the new node. Insert a node at this position. Clear? At this position. Now, first you need to at this position. I is equal to 0. 0 less than 3 minus 1, that is 2. The condition is true. Now what I am doing? Temp is equal to temp dot next. That is, I am using some temporary variable. Initially, the temporary variable is head. Yes. So before the position, I am moving. So temp is equal to temp dot next. Now, initially, this is temp. I is equal to 0. 0 less than 2, temp is equal to temp dot next. Now this is the temporary. In the next iteration, I is equal to 1, 1 less than 2, and this is the temporary node. Clear? So I want to insert at position number 3. Right now I am at position number 2. Remaining logic, you know, as usual in single linked list. As usual in single linked list. So what is the logic? What is the logic? You need to place right side link first. How do you place the right side link? That is in the next field. Whatever the next field of temp, that is assigned to this one. So new node dot next is equal to temp dot next. Got it? What is the temp dot next? This node. From now onwards, this becomes the next node of new node. That is the reason I return. After that, temp dot next is not this node. After that, temp dot next is equal to new node. Clear? Now the node is inserted successfully. This is very good. Suppose I given a position is equal to 7. Assume I given one position. Suppose the position is equal to 7. What happened? Here first 0, 0 less than 2, temp is equal to temp dot next. This is the temp. In the next iteration, temp. In the next iteration, this is temp. In the next iteration, this is temp. In the next iteration, this is temp. This is temp. In the next iteration, temp dot next. Again, this is temp. At position 5 only, I stopped the process. But I given position 7. That means the position is not at all available. Means while traversing, you need to check the condition. If temp is equal to head means The position is not available. Yes or no? The position is not available. Suppose at I is equal to 5, temp is at this position. Temp is at this position. And temp dot next, in the next iteration, temp is at this position. Temp is equal to head. Stop the process. Now, I is equal to 5. Suppose if I given I is equal to 5, then what you need to do? Temp moves up to this position. Same. Suppose I is equal to 5. Temp moves to this position. Here you need to insert a node. You need to insert a node at this position. Suppose I is equal to 6. I is equal to 6. My temp is at this position. Same logic. New node dot next is equal to temp dot next. Any position, the logic won't change. Clear? Even position 0 also, the logic is not at all changed. Clear? Now, write down that one also. Public node insert position. Here two parameters into data into some position. Into data into some position. Anyway, what is the first step? Create a node. So one node is created. So first case, if position is equal to 0, before that I used one temp is equal to head rs. Even though not a sin, not a problem. If position is equal to 0. What is the meaning? If position is equal to 0 means you are doing insertion at the beginning. You are doing insertion at the beginning. Else. Now coming to the case. Else means you are doing inserting at any other position. Now for int I is equal to 0, I less than position minus 1, I plus plus. Within the loop, what I am doing? Temp is equal to temp dot next. The temp moves to the next position. Suppose while moving at any point, if temp is equal to head, while moving, if temp is equal to head, what is the meaning of this one? What is the meaning of this one? If temp, that is the last node is already crossed. My position is not at all available. I am crossing the last node. My position is not available. So system dot out dot println position not available and simply return null. If is completed, now for is also completed. Once the position is available, simply return the logic. New node dot next is equal to temp dot next and temp dot next is equal to new node. The connections are established. This is closing of else. See, this is if condition, this is for, and this is else. This is the closing of method. Now, closing of my entire class circular linked list. Now, class, create one class for main purpose, class demo circular public static void main. Okay. Within this main, what you are doing? Create an object for this class. Why? If you want to access the members, you need to create an object. Circular linked list. Some OB is equal to new circular linked list. OB dot insert begin of some value I given 10. Okay. I am doing some two insert begin operations. After that, along with you need to write one more method. What is the method? Insertion is successful, fine. You need to display the values, yes or no? After completion, display is compulsory. Otherwise, how do you print the value? So, write down the display method also. Write down the display method also. Simply public void display of same node temp is equal to head. Node temp is equal to head. The first node I assumed as temp node do system dot out dot println temp dot data. Now temp is equal to temp dot next. While temp not equal to head. This is the circular linked list. Before this, first you need to check one condition. What is the condition? If head is equal to null means print the message system dot out dot println list is empty. Now do all the close operations. This is do while, this is closing of display, everything is fine. Now after doing insertion, ob dot display of, fine. Now save the program. Dot Java C space demo circular dot Java. So just spelling mistake only, that's not a problem. Capital and small. Here position is okay. At this one, no. At this one, no. Clear? Save and execute. Compile the program. One missing statement. Now compile the program. Java space demo circular. So see, the elements are inserted. So 30, 20, 10. So what is the logic? I do insert at beginning. First 10 is inserted, before that 20, before that 30. Suppose here I am using this statement. Now observe how the elements are inserted like this. Similarly, call ob dot insert end of some 100, ob dot insert end of some 200. After that, call the display method. Save and execute. Observe 30, 20, 10. This is the first to display. After that, 30, 20, 10, 100 and 200. So I am removing this display. Okay. Now observe clear. The first three insertions at the beginning, next to insert at the end. Now what I am doing? ob dot insert position of some 300 comma position number 2. Save. What is the position? 0, 1, 2. At the second position, you are inserting 300. Check whether it is right or wrong. Yes or no? This is 300. Like this, you are doing insertion operations in the circular linked list. In the next session, we will move to deletion operations in the circular linked list. That's the end of today's session. Thank you.